Morning children, we are going to start with the chapter Trigonometrical Ratios. As it says that it is a ratio means it will be a ratio of sides of a right angle triangle. The entire trigonometry depends upon, revolves around a right angle triangle. So first of all, you should know what all are the properties of a right angle triangle. We have a 90-degree angle and the other two angles are acute. The side which is opposite to 90 degree is known as hypotenuse and the other two sides are known as perpendicular and base. But here the two acute angles which we'll have, they will decide that which line will be treated as perpendicular and which line will be taken as base. Okay, so if we see this triangle, the first triangle, in triangle ABC, in first triangle ABC, B is 90 degree and I have taken angle C, acute angle C. So opposite to 90 degree it will be hypotenuse, and the acute angle which we are taking, opposite to that, the line segment which will be there opposite to the angle, acute angle taken, will be treated as perpendicular, and the third remaining side becomes the base. So if we take triangle ABC and if we take angle A, acute angle A, then according to angle A, opposite to angle A, it is BC, line segment BC will become the perpendicular and the leftover side will become base. So AB becomes the base because hypotenuse is always certain, it is definite. Opposite to 90 degree angle, that means AC will be hypotenuse. Clear? If we calculate the ratio of two sides of a right angle triangle, okay, then the ratio is termed as trigonometrical ratios. Their names are sine, cos, tan. These are the short forms which we use. The complete spelling is SINE, but in short we use SIN. It is not sin, it is sine. It is read as, pronounced as sine. And cos, it is cosine, COSSINE, and tangent. Clear? But let me tell you that sine, cos, tan, they do not attain any value if we have not written angles with them. Means we should write, in general we can write angle theta like sine theta, cos theta, tan theta. We can write any numerical value like sine 36 degree, cos 49 degree, tan 90 degree. Or we can take the vertex of the triangle as the angle. Like we can, in this diagram, we can take this angle as angle C. That's why we have written sine C. So the formula says that sine theta, in general, sine theta is equal to perpendicular upon hypotenuse. In general, cos theta is equal to base upon hypotenuse. Tan theta is equal to perpendicular upon base. Here I have not used angle theta so that you may relate it, which side will be taken as the perpendicular and which side will become a hypotenuse and what will be taken as base. So if we take angle C with them, so sine C, so let us decide what is hypotenuse, what is perpendicular, what is base according to angle C. Opposite to 90 degree, AC becomes hypotenuse because we are taking angle C, sine C, we are calculating sine C. So according to angle C, AB becomes the perpendicular because it is falling opposite to angle C. So AB becomes the perpendicular. The leftover side becomes the base. Clear? So sine C becomes the perpendicular upon hypotenuse, that means AB upon AC. Likewise, cos C, these are the formulae, base upon hypotenuse. So base is BC upon AC. Tan C is equal to, formula is perpendicular upon base, so AB upon BC. We have some reciprocal relations. Reciprocal means sin C becomes 1 upon sin C. So 1 upon sin C is known as cosec C. 1 upon cos C is known as sec C. 1 upon tan C is known as cot C. Clear? You can take it as 1 upon sin theta is equal to cosec theta, 1 upon cos theta is equal to sec theta, 1 upon tan theta is equal to cot theta. Clear? And because they are the reciprocal, so it becomes, instead of perpendicular upon hypotenuse, becomes hypotenuse upon perpendicular. Cos theta was base upon hypotenuse, will be reciprocal, becomes hypotenuse upon base. Likewise cot also. Clear? What will be there if we change the angle? Now I am taking angle A with all the trigonometrical ratios. Okay, sin A, tan A, cot A. We will calculate trigonometrical ratios with angle A. So if we take acute angle A opposite to angle A, BC becomes the perpendicular. AC will be definitely hypotenuse, and the leftover side AB becomes the base. So we will again write all 6 trigonometrical ratios according to angle A. So angle A is equal to perpendicular upon hypotenuse, and it becomes BC upon AC. You can see that earlier it was sin C was AB upon AC. Now sin A is BC upon AC. Value will change. If we change the angle, the values of all trigonometrical ratios will change. But these formulae remain same. Perpendicular upon hypotenuse, sin theta, cos theta base upon hypotenuse, tan theta perpendicular upon hypotenuse, and if it will become reciprocal, then cosec theta will become hypotenuse upon perpendicular, sec theta will become hypotenuse upon base, and cot theta becomes the base upon perpendicular. Clear? These were the reciprocal relations. Clear? Now one more thing is left out. It is a shortcut to learn all these formulae. It is written as PBP HHB. You can formulate, you can decode it as per your wish, but what I use is this: Pandit Badri Prasad Har Har Bhole. Clear? Pandit Badri Prasad Har Har Bhole. So P upon H, perpendicular upon hypotenuse is sin theta. B upon H, base upon hypotenuse is cos theta. Perpendicular upon base, it is tan theta. And if we write cosec theta, then hypotenuse upon perpendicular, sec theta hypotenuse upon base, and cot theta base upon perpendicular. If you watch them carefully, then I'll take you on the first slide. It is sin C and cos C. If we divide sin C by cos C, then sin C upon cos C is equal to this thing divided by this thing. It means hypotenuse and hypotenuse will be cancelled, and we'll be left out perpendicular upon base. And perpendicular upon base is known as tan theta, tan C. Clear? So what conclusion we can draw? We can draw this conclusion that tan theta is actually sin theta upon cos theta. And because tan theta is equal to sin theta upon cos theta, so reciprocal of it, 1 upon tan theta is cot theta, and if we reciprocal it, then cot theta is equal to cos theta upon sin theta. One more thing you have to remember, that you have to keep in your mind कि trigonometrical ratios, they do not have any unit, because we are dividing centimeter, divided by centimeter. Generally they are in centimeters, but otherwise these are the lengths which are divided. Clear? So they do not attain any unit. Ratios do not attain any unit. Clear? So moving on to the exercise, how to apply them. It is question number 1. Okay. From the figure, we have to find out the value of tan x, cos y, cosec square y, cot square y, minus cot square y. Always remember, all these perpendicular, base and hypotenuse, they will keep changing according to the acute angle. We need to first of all look for whether we have a right angle triangle or not. Okay, it should have a right angle triangle, otherwise we cannot apply trigonometrical ratios. We cannot find. We should have a 90-degree angle. And then the second thing, we have to look for the acute angle, and according to that only we'll decide what is perpendicular, base and hypotenuse. So first of all, in a triangle ABC which is given, AD is perpendicular and few of the sides have been given. So we are going to, with the help of Pythagoras theorem, first we will calculate the missing sides. Clear? So here in triangle ACD, if we look in triangle ACD, AC is 13, which is hypotenuse, and CD is given 5. So we have to find out AD. So with the help of Pythagoras theorem, if we calculate, perpendicular square is equal to hypotenuse square minus base square. So it becomes 169 minus 25, that means 144, and AD becomes under root of 144, that means 12. We are taking only positive values because negative values, length of side cannot be negative. That's why we have ignored it. Complete BC is given 21 and CD is 5 centimeters. So BD will become 21 minus 5, that means 16 centimeter. Now if we look in triangle ABD, BD we have just now calculated 16, AD we have just now calculated 12. So we, what is missing? AB. We have to calculate AB. Once again, if we apply Pythagoras theorem over here, so hypotenuse AB square will be equal to base square plus perpendicular square. So 12 square plus 16 square, that means 400, and AB becomes 20. Clear? So now we have calculated all the values here. Now first thing is tan x. So we'll look the triangle in which angle x has been given. It should have a right angle triangle. So triangle ACD is a right angle triangle in which we have the acute angle x. So according to angle x, CD becomes, because opposite to x we have CD, so CD becomes perpendicular. And opposite to D, it is 13. AC, it becomes hypotenuse, and left over AD becomes the perpendicular. So AD is perpendicular and AD is base and CD is perpendicular. Clear? So tan x will be equal to perpendicular upon base. That means CD upon AD. I'll take you there, then you can relate it once more. Perpendicular is CD and base is AD. So CD upon AD. 5 upon 16. 5 upon 12. Cos y. Okay. Cos, the definition of cos theta is base upon hypotenuse. But we have to look for a right angle triangle in which we have angle y as the acute angle. So we will go in triangle ABD. Opposite to angle y, it is AD. So AD becomes the perpendicular now. Earlier it was base. Now AD becomes the perpendicular. So AD is perpendicular. It means BD, leftover side, will become base. So base is BD and hypotenuse is AB. BD upon AB. Clear? Cos y becomes BD upon AB. 4 upon 5. We will calculate it. We have put the value. Cosec y. Angle is same. It means we have to cosec y. The definition says hypotenuse upon perpendicular. So according to angle y, AD is perpendicular and AB is hypotenuse. So AB upon AD. Hypotenuse upon perpendicular. Are you getting it? AB upon AD. 20 upon 12. That is 5 upon 3. Then cot y will be equal to